Welcome to Systems Are Go. My name is Eric McLaughlin, and I'm the astronomer for the Rancho Mirage Library and Observatory. And this time we'll be looking back at the data from the observatory for November 2021. Let's jump right in with our all-sky camera views of the night sky. We had several interesting sights in this footage this month. Our owl friend visited early in the month. We had a wonderful view of the lunar eclipse on the night of the 18th and 19th. And we even caught a view of a bright meteor on the night before Thanksgiving. Of course, we also had a lot of great views from our solar telescope, but we'll talk about that later. For now, enjoy these views, and I will be back shortly. the evening of the 18th, despite less than ideal observing conditions, we had a lovely midnight showing of a near total lunar eclipse. We also had a live stream of most of the umbral portion of the eclipse, which you can view on our YouTube page. At the point of greatest eclipse, the moon was around 97% in the umbral portion of the Earth's shadow. While this image appears a bit pink, to the human eye it looked more red at this stage. On the evening of the 24th, the global Fireball Observatory network of all-sky cameras captured 3 images of a fireball. The images were taken at sites 21, 20, and 18, operated respectively by Jim Albers, Jason Utas, and Natalie Swingle. The 3 images were used to build this model of the fireball's trajectory. The model also yielded estimates on the object's final speed and mass. Adrien de Villepoix from Curtin University reported that the object was between 50 to 100 grams at the last pick point, where it was moving 7.7 kilometers per second at 38 kilometers in altitude. It clearly continues in the picture, but we cannot resolve the timing, so we are at best looking at a small survival mass dropped from a high altitude and at a very shallow angle. Now, we can use this model to estimate what we should have seen at the observatory. From our perspective, it should have descended right across the peaks of San Jacinto. This means that the observatory dome will have blocked the view from our GFO camera. However, from the other all-sky camera, we should expect to see a streak of light right near the bottom of the image. Right there. In science, it is always great to see a model directly validated by observation.
And now let's review the weather station's data for November. This month, our temperatures sat rather stably around the mid-range of temperatures common to the valley. For relative humidity, things have trended slightly drier as the month went on. And now that temperatures are cooler, that dryness is a bit more noticeable. Now for November's heat maps. These plots show how the temperature varied for every hour of the month. In these plots, each day is represented as a column which progresses upwards, with morning towards the bottom, noon in the middle, and evening near the top. The color scale in this view is set to span all the temperatures we generally see here over the course of the year. This month continued to hang right in the mid-range of the temperatures we generally expect to see out here. Now when the colors are scaled based only on the temperatures we saw in November, we can see the variations within the month more clearly. Now let's bring these observations together into our temperature and humidity scatter plot. The white curves shown are the water vapor density contours. If data follows along one of these lines through time, then the amount of water in 1 cubic meter of air is not changing significantly in that time frame. In this animation, the data from each hour in November gets its own frame. Here we can see the slight decrease in both temperature and humidity quite well. Now with all the data from November plotted, let's see it in the context of the past year. And now let's view the data with a cyclic color map. Finally, let's view the images from the solar telescope. These images are taken through an H-alpha filter and are then colorized to show more detail. H-alpha refers to a specific wavelength of red light. H-alpha is emitted from hydrogen in rather specific physical circumstances, the kind that are found in the sun's chromosphere, which is a region above the photosphere, what we would refer to as the visible surface of the sun. We had several good sunspot groups and filament activity this month. Sunspots occur where the sun has concentrations of magnetic flux passing through the photosphere. Likewise, filaments are dark linear features caused by cooler material moving along magnetic field lines above the surface of the sun. They are the same thing as solar prominences, which are visible on the edge of the disk of the sun. However, we generally do not see prominences in these views because we would need to adjust our exposure settings in a way that would wash out the rest of the sun. Anyway, enjoy this safe method of looking at the sun, and I will be back as we close.
Thank you for watching this episode of Systems Are Go. We would like to give a special thank you to the Rancho Mirage Library and Observatory Foundation for making programs like these possible. We hope you enjoyed your time here today, and if you'd like to be kept up to date on all our programming, please follow the link in the description below to sign up for our e-newsletter or subscribe to our channel on YouTube. Thanks again, and remember to keep on looking up.